Sub D is easy as pie once you understand these three secrets of topology: purpose, flow, and tension. Let me show you what I mean. Before we start, let me tell you that there is a fantastic course for anyone who wants to learn hard surface modeling in Blender quickly and efficiently. The course is free and it's called Jumpstart Hard Surface in Blender. We have over 80,000 students who enrolled and they absolutely love it. In just a few hours you can learn all the basics, all the tools, and understand how it all works, so you can start feeling more confident and start creating your own stuff in Blender with ease. The link is in the video description, and like I said, the course is free, so go ahead and get it. Before we're gonna talk about the triangles and n-gons and subdivision, let's talk about the biggest myth on the internet, and that's you need to create everything using quad topology and subdivision. That is the biggest bullshit I've ever heard. Topology is a tool, so you need to use a specific tool for a specific purpose. When you're making a sandwich, you're not gonna be using a hammer. So when you're creating a game asset for a game, and it's a hard surface game asset, it's not organic, it doesn't deform, you do not need quads, you can use n-gons, booleans, whatever. It's even better because the topology is going to be less dense, so the object's going to be lighter, and you can texture it without problem, and we have a whole course showing you how to do it. So that's a myth. Now, the truth is that you do need to consider the purpose of your model, and you need to use correct topology for that purpose. So let's say you are working in VFX for movies, you're probably gonna need quads because stuff over there needs to be very, very clean, close to the camera. The shading has to be perfect, and that requires very, very clean and very uniform quad topology. Now, there are exceptions as well, because when you're working in films or production and you have something far away from the camera, you are fine with n-gons. So even in production, n-gons are fine. Again, you need to understand what is the purpose of a specific model. Now let's talk about subdivision, triangles, and n-gons. So can we use triangles and n-gons when we're using subdivision? Now the first thing we need to address is, like, why are we even asking that question? The reason why we're asking this question is because of how quads and n-gons and triangles are being subdivided. So let me just show you very quickly, okay? So I'm gonna create three examples here. Let me just nuke these together, and here we're gonna create an n-gon, okay? So let me just subdivide it, okay, and we just do something like this, and that's an n-gon, okay? If I'm gonna take a quad and subdivide it, you can see that the subdivision is very predictable, okay? It goes across in the middle of each edge and goes across the edge, right? So it's very predictable. No matter what kind of quad you have, you're gonna have the same result: middle of the edge across the quad. Now triangles are gonna be subdivided a bit differently. You're gonna be basically getting diamonds of 3 diamonds, which are gonna be 3 quads. So each triangle can be subdivided into quads, but it's also in a way predictable subdivision because you know how it's gonna be subdivided. Of course, triangles can have different sizes and forms, but the subdivision is going to be predictable. Now the problem is n-gons is that we never know how they're going to be subdivided, okay? So if I'm going to subdivide an n-gon, it could go like this, okay? And then you're going to have subdivision going like this here, right? Possibly. And this is not a uniform subdivision because you can see that you have massive faces here and tiny faces here. Another way of subdividing this could be, for example, that way, right? So again, very different subdivision here, like this, right? So there are multiple ways in which n-gons could be subdivided, and you cannot predict which way the software is going to choose. So this could impact topology flow and therefore the shading tension on a mesh, and that's why you need to be careful with n-gons and triangles, but more with n-gons. Now let's look at a practical example, okay? So if I'm going to grab a mesh here, and I'm going to extrude it right like this, and I'm just gonna grab this one here and extrude it, drop it here, and I'm going to subdivide it. Everything gonna be peachy because we have a more or less even quads, and none of the quads are actually bent, they're all straight. Now watch what happens when I'm gonna apply one level of subdivision here, okay? So now let's see what happens when I'm gonna move this edge here, slide it, and I'm going to subdivide this mesh, right? So I'm gonna, curve it. This face is gonna be bent, okay? You see that it's bent? And this may create some shading problems on the mesh because again, these faces are bent. Whenever you have bent polygons, doesn't matter if it's quads or n-gons, you cannot bend triangles because they only have 3 points, but you can bend quads and n-gons. So when you have bent topology, this is bad news. This is what creates shading problems, okay? So even though I have perfect topology here, I got all quads, you can clearly see there's a distortion here. It's clean shading here, and there is a wobble in here. And that wobble comes, the flat spot here, comes from this massive quad. So even if you have all quads, you're not safe. You need to know what is the quality of your topology and how your topology is spaced across your mesh, especially on curvy surfaces. Now let's look at a different example. We're going to grab a plane here and we're going to extrude it like that. And we're going to create a curve in here. And we're going to subdivide it like this, so we have more or less even topology, right? And we're going to subdivide it. So now with this topology, let's go here, right? And create an n-gon in here somewhere, okay? So let's just dissolve this, and this is a massive n-gon, 2 triangles, terrible topology. And let's see how this impacted our shading. Our shading will not change, and I'll tell you why, because it's a flat surface. But look what happens if I'm going to change these 2 quads here, okay, into triangles, you see? Boom. That's already caused some issue because we have a change in tension here, and also these are slightly bent. And this is your answer again, bent topology. But if I'm going to combine these two, the shading impact is going to be minimal, okay? Because these actually are not bent. They're quite fine. So even though we have 2 triangles in here, that these quads are not bent, and there is no really shading distortion here. See, the reason why this happens is because the topology flows, upwards along with the curve. So technically, when I'm going to combine these two, the flow of topology doesn't change. But when I'm going to combine these two, my topology flow changes because it gets locked in here. So in understanding topology flow and topology tension are 2 most important things, and also topology shape. So when you bend something, right, these are essential to understanding shading with subdivision. So you can get away with triangles, you can get away with n-gons, but you need to know what the hell you're doing. Another thing that's really important to understand is size of topology. So when I'm going to apply a really fucking dense topology, I mean crazy dense, right? Now with such dense topology, you have a bit more leeway, to get away with, right? So you can get away with more than usual. So let's say I'm going to create an n-gon in here, right? So, you can clearly see there's an n-gon here, and there's a bit of a distortion here in this area. You can see this here, right? But it's barely visible, okay? You cannot see this with a naked eye. And the reason for that is simply because the topology is so goddamn small that it doesn't bend. You see that n-gon is straight. So even though when I'm going to subdivide it, right, and the subdivision is not going to be super clean, it's going to subdivide it really ugly because all the flows are going to be distorted in here. It's working because this topology is so small. There will be moments in your sub-D modeling where you do have to use different topology like triangles or even n-gons, and you're going to be fine. Another example I can give you is with cylinders, which is really, really interesting, right? So I'm going to run some loops here, Control R, boom, right? And I'm going to subdivide it. Of course, it's going to collapse on the top here because we have a massive n-gon, right? But look what happens when I'm going to insert it twice, right? There's no shading distortions whatsoever anymore. And since we have nice and even topology here, we don't have any pulls. So, this bevel is nice and smooth, especially when you're gonna subdivide it one more time and maybe remove this edge here. Then you're gonna have this nice even bevel here because you have edges spread more or less evenly around this bevel, okay? Because the more even topology, the cleaner the curvature, remember. If I'm going to move this edge, for example, lower, you see that the curvature changes. But, here we have a massive n-gon, and you can get away with it because, again, it's a flat surface, and it doesn't really do anything. So if you don't have to, have quads in here, then just don't do it because you're gonna be wasting time. Alright guys, well that's it for this video. Hope it helps you out and it's gonna answer some questions you may have about topology, and hopefully it's going to demolish this stupid myth going about that everything needs to be in quads and quads are the only answer. It's not that simple, it's a bit more complicated. Thanks for watching, I'll see you in the next one.